Vector database are the memory layer behind every serious AI application, and most developers skip understanding them. In this video, I break down exactly what they are, how embeddings work, and how FAISS powers the RAG layer in my AI Career Mentor project. We will talk about what is a vector database, what embeddings actually are, how semantic works, FAISS versus pinecone versus chroma, which to use and when. Hi, this is Anwesha, senior STE with 6 years building career. I worked in fintech, MNCs, and AI startups. I don't just teach I have built it in production. I built a RAG knowledge assistant that had accurate, fast, and hallucinated control. And I've run it in fintech. Yes, wrong answers cost real money in fintech. So, with this channel, I am building you two series. One, backend to AI development, where I am building an AI career mentor from scratch. We'll talk about multi-agents, RAG, MCP, vector database, real code, no fluff. With every episode, we'll ship something. The second series is Let's Talk, where AI concepts will be explained through the things which I'm actually building there. No jargon, no hand waving. The mental modes that actually work. Being the university gold medalist and with 6 years of fintech scale experience, I am building it in public and follow along to learn more about. We are posting new video every week. So I was building an AI that could read your resume, understand your career goals, and give you a personalized roadmap. It worked. Kind of. The problem was it forgot. It forgot everything the moment you closed the tab. Every conversation started from zero, like talking to someone with amnesia. And I had no idea why. And so the fix was a vector database. And once I understood what it actually was and just not how to install it, everything about how AI systems, store and retrieve knowledge clicked into one place. And that's what the video is about. So if you have been following along, I have been building an AI career mentor from scratch. First, we did the basic Ollama setup. The RAG, then MCP, then multi-agents, a vector database was quietly powering the memory layer. This whole thing. Today I am pulling it out and explaining it properly. So what is a database? Let's start with a regular database. When you are storing data in Postgres or MySQL, you are storing exact values, right? Like name, age, job, title. And when you search, you're looking for exact matches. Give me everyone named Anwesha. That will be an exact match, right? Clean, simple, works great for structured data. But here's the problem. When I upload a PDF resume to my AI mentor, there are no exact keywords to match against. I need the AI to understand the meaning. I led a team of 8 engineers and managed a backend squad to mean the same thing. But a regular database sees them as a comparatively different strings. So the analogy is a regular database is a library where books are sorted alphabetically. A vector database is a library where books are sorted by feeling. Walk in and say, I want something melancholy, right? About loneliness. And it finds the right self, not by title, by meaning. So, yes, my friends, a vector database stores data as numbers, specifically, list of numbers called vectors or embeddings. The numbers capture the meaning of the text, not just the letters. And when you search, you are looking for an exact match. You are looking for the closest list of numbers that represents meaning. Take the sentence, I want to transition into AI, right? A model converts that into maybe 384 numbers. Something like as shown here. all the way to numbers. That's the embedding. The analogy could be a GPS coordinate. Think of it like GPS coordinates for meaning. Every sentence gets a location. Every sentence gets a location in meaning space. I want to move into AI and I am transitioning into machine learning. End up very close to each other on that map. And I want a pizza ends up somewhere completely different. So in my project, I use a library called sentence transformers to create these embeddings. It takes any text, a whole PDF resume, and converts every chunk of it into a vector. Those vectors get stored into files. That's the vector database I'm using. From sentence transformers, importing that, right? The model, that example that you can see, right? Model is equal to sentence transformers and those stuff. And then embeddings into model. Now, how search actually works in vector database. So you have stored all your vectors. Now someone asks the AI mentor, what skills do I need to become a staff engineer? Here's what actually happens step by step. Question is converted into embedding, FAISS, then does the nearest neighbor search, chunks are retrieved, and the LLM gets the context. So the question gets converted into a vector. Same process, sentence transformers, turns it into 384 numbers. The FAISS does a nearest neighbor search. It finds the vector already stored that are closest to the meaning to that question. And then we match the chunks of the text, get pulled out and handled to the LLM as context. The LLM didn't memorize anything. It just got the relevant pieces handled to it. Analogy could be an open book exam. The LLM is a student taking an open book exam. The vector database is the index at the back of the textbook. When a question comes in, instead of remembering everything, it flips into the index, finds the right pages, and reads them and answers. Faster, more accurate, doesn't need to memorize the entire book. This is literally what RAG is, retrieval augment generation. The retrieval part, that's the vector database. So yes, just the 2 lines in my actual code base. As I promised, the 2 lines. Here they are. Line number 1 and line number 2, as you can see in the slide. AI Career Mentor, after a chunk, the resumes the PDF using PDF Plumber and create the embeddings with sentence transformers. This is all that FAISS needs. Index is equal to FAISS.index flat LT dimension. And index.add np.array embeddings. That's it. 2 lines to store all of it. All of the knowledge. Line 1 creates the index, essentially an empty vector space. Line 2 adds all the embeddings into it. FAISS handles all the nearest neighbor search internally. No database setup, no schema, no migration, just the vectors. Let it land. Yes. When I first saw this, I genuinely thought I was missing something. Surely there's more. No. There's an entire storage layer for a system that can read a 10-page resume and answer detailed questions about it under 2 seconds. My multi-agent system, the one with 5 specialized agents for resume, skills, roadmap, salary interview, every single one of these agents queries in the same FAISS index, 1 vector database, 5 agents, 1 source of truth. So yes, we'll talk about FAISS versus other vector databases. Now, FAISS is the only vector database out there. It's what I use because it runs locally. And it's incredibly fast for the scale I needed. But here's how it compares to what you'll hear about it in production system. FAISS, what I used was in memory, local, no server was required, perfect for prototyping. Personal projects running on your own laptop with Ollama, no cost. Right? Chroma. It's open source, easier API than FAISS, persistent storage, good middle ground for local development that you want to scale later. Pinecone is cloud hosted, managed scales to billions of vectors. You pay per query and production apps use this. Vivient or Quadrant, full vector database, servers with REST API. When your app goes beyond a single machine, that's when you need it. So for where you are in your journey, building, learning, shipping, FAISS or Chroma is the right call. But if you want to do it in production, right, go for Viviet, Quadrant, Pinecone. Don't pay for Pinecone until you have users who justify it. So what changed when I understood these? Before I understood vector databases, I thought RAG was the magic. I just somehow remembered thing. Now I know exactly what's happening. The resume gets chunked, the chunks becomes vectors, the vectors go into FAISS. When a question comes in, the closest vectors come along. The LLM gets its context, it answers every single time. That's not magic, that's a system. And once you see it as a system, you can debug it, improve it, swap out parts. That's the shift from user to builder. One thing to do, your action item is to open a project where you are passing text to an LLM. Ask yourself, where is the text coming from? If the answer is, I am just putting it in prompt manually, that's where a vector database belongs. That's your next upgrade. The full code of the AI Career Mentor, the 5 index, the 5 agents, the MCP setup, all of it is in the GitHub, linked in the description. Clone it, break it, learn from it. Next week on Let's Talk, we'll have tokens, context windows, why your AI forgets, why it matters more than the model size, and then one mistake I made that cost me 2 days of debugging. See you then. Until then, hit a like if you have loved it, or let me know in comments below if you want to know something else, or would want something else to learn from here. Until then, it was nice. Thank you. Bye bye.